Hello class, and welcome to today's algebra lesson, which is about scatter plots, correlation, and causation. By the end of today's lesson, you will be able to identify the types of correlations and determine the difference between correlation and causation. So we're going to start with a little introduction to scatter plots. Scatter plots are a way to visually illustrate bivariate data. What bivariate data means is that it is two sets of variables coming together. So for example, we could say the amount of oranges in a bag and the weight of the bag. There's two separate categories that we are combining into one chart. The scatter plot is that visual chart that we have. The trend is the general direction that your bivariate data or that your scatter plot is moving in. There are three different types of trends. The first is called a positive correlation. This is where the general format of your data is increasing. So as your x variable increases, your y variable increases. This would be like the example I stated earlier. As the number of oranges in a bag increases, the weight of that bag is going to increase. So both values are going up. If our next correlation is a negative correlation. This is saying that as one variable increases, the other one is going to decrease. So you could think about this if you are at a popcorn stand and you have a certain number of boxes to sell at the beginning, and then throughout the day, those decrease. So your time, the amount of time you have been selling, increases, but the amount of boxes that you have left to sell decreases. So the general trend is going down. Then the last option is no correlation. The two variables don't really actually belong together. This could be as something as absurd as the number of cars in a parking lot and the number of pine cones on a tree. Those two things don't actually go together, and that would be illustrated in the particular set of data. So each trend is a general rule. It is not a perfectly straight line going up or a perfectly straight line going down. It's the general flow of the points. The cluster is the main point that you are looking at for the trend. So if we come back here, our cluster of data is this group right here. We have one point that's way up at the top, but the general trend of our data is going to go up. An outlier is something that is very far off from the trend. So for example, if there was a point up here, let me grab my pen. If there was a point up here on the top of my positive correlation, the general trend is still positive. There's just one piece of data that doesn't really fit. This red dot would be an outlier. When you are looking at correlation, you can ignore the outliers. Now on this no correlation one, we have a lot of points spread out, so there's not really any outliers ever in a no correlation. It's the positive and negative that might have 1 point or 2 points that don't really match the trend, and those are your outliers. The last piece we're going to discuss is causation. So correlation just means that the general trend of the graph is moving in the same direction. We can talk about causation when one thing is actually causing something else to happen. So if we go back to the oranges example, as you add oranges to a bag, that causes the bag to get heavier. Or it could cause the bag to get heavier. The oranges might not weigh that much, so who knows? Causation is a general idea that one thing could be the reason why the second thing is changing. So we're going to start by just looking at correlations. So for example, A here, I have the height of a particular shrub and the number of blossoms on that shrub. As I look, there's not really a clear pattern in this data. So this would be no correlation. And then we want to make sure we always give an explanation as to what is happening. So we would say no correlation. The height of the shrub does not correlate or does not relate to the number of blossoms. There's no clear pattern for what we are looking at in this particular data set. So there's no correlation there. If I come to look at the next one, we have the popcorns purchased and the profits made. When we look at this, the general trend is going up, so we would say that this is positive. And then once again, we want to do a little bit more explanation so that we know what is happening. We would say as more popcorn is bought, the money made also increases. So we want to give an explanation for what is happening on that graph. As you buy, as more popcorn is bought, the people selling it make more money. Go ahead and try problem C on your own. So our general trend here is negative as the years are increasing. So 2001, 2, 3, 4, 5, etc. The number of landlines is decreasing. So people don't have home phones as much anymore. Go ahead and try D on your own. General trend of this one is going up. As the height of the person increases, so does their weight. So a general trend of moving in a positive direction. Next thing we're going to look at is correlation versus causation. We're going to start by looking at that on a graph, so we have a visual thing to see. This particular graph shows that the data per capita of the consumption of mozzarella cheese, so how much cheese people are eating, and the number of civil engineering doctorates degrees that are awarded. So if I look at my graph right here, it is following a positive correlation. It is going up. So that's our first job, is to talk about the correlation. So we've got a positive correlation, which indicates that the more cheese eaten, the more doctorate degrees are earned. So that's what our graph is telling us. Now, our next job is to decide, is that just a correlation? Is it a coincidence that it so happens to be as more people eat cheese, more people also get doctorate degrees? Or is it a causation? Eating cheese is causing people to get civil engineering doctorate degrees. In this case, it would just be a correlation. I know this seems silly to talk about, but most of these, you can find trends in data where two things are both increasing, but they actually don't relate to each other. So this would be correlation, because eating cheese does not cause people to earn doctorate degrees. Now, if this bottom part had been number of hours studying and the amount of civil engineering doctorate degrees earned, those two could relate to each other. The more time people spend studying, the more degrees are probably earned. So you want to look at the logical piece behind it and decide, does one thing actually cause the other to happen? Go ahead and try this one on your own. First, I want you to just determine the correlation. So in this case, we have a negative correlation. The more classes you miss, the lower your exam score. Now decide if this is correlation or causation. This one in this case is going to be causation. The more classes you miss could cause you to do worse on a test. It's not a guarantee that missing more class is going to make you do worse, but it is a possibility. So it could cause this to happen. We also want to be able to do this for scenarios without graphs. So a university study shows a negative correlation between the average weekly time spent exercising and the probability of developing heart disease. So right off the bat, they already tell us that there is a negative correlation. It is already trending down. So as you increase the time you spend exercising, you decrease the probability of developing heart disease. So the first thing you'd want to do is determine the two variables. Increase in exercise means decrease in heart disease. Then you need to decide, are those two just coincidence, or could one actually cause the other one? In this case, this is going to be causation. More exercise can cause, we can't guarantee it, so we always want to say can cause a lower chance of heart disease. So again, we don't want to guarantee that exercising is going to lower your chance of heart disease, but it could be a causing factor. Go ahead and try this one on your own. In this case, it is just correlation. The amount of chocolate eaten by a particular country does not actually cause them to win more Nobel Prizes. If you have questions about this or anything else from the lesson, please feel free to reach out and let me know.